In this video, we are going to learn about probability distributions. First, let's figure out what a probability distribution is. Well, it's basically a visual representation of all the possible values that your random variable could be, plus the probabilities for each of those values. So a probability distribution takes on three pretty typical forms. It could take on the form of being a table, it could also be a graph, or it could be a chart. But the key things that it has to have or has to show are the possible values for the variable that you're talking about, your random variable. And remember that your random variable is usually denoted by the letter X, capital X. And it also has to show the probabilities for each of those possible values. And as long as it shows those two things, that will be a probability distribution. It's a visual that shows you everything that you sort of want to know about that random variable and the probabilities for each of the things it could take on. So let's think about an example. What if we were to roll 2 dice and our random variable was the sum that came up? So we can first make a chart to keep track of what all the possible sums are in order to then make a probability distribution. Now that we have a table that shows the possible sums, we can make a probability distribution. The two key parts of our probability distribution are a part that shows the possible values for the variable, in this case that's the possible values for the sum, and also the probability for each. So I'm going to make a table that has two columns, one for x and one for the probability of x. So first let's think about what are all the possible values of x. And x is the sum of the numbers. So the possible sums are 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So every number from 2 to 12. So I can write that out. And now I just need to fill in the probabilities for each of those values. So if x is 2, over here, we want to fill in what's the probability that the sum is 2. So if we look at our table or our chart over here, there's only one place where the sum is 2, 1 out of 36 boxes. So the probability is 1 out of 36. And you would do the same thing for each of the different values of x. So if x is 3, we can see there are two places where the sum is 3, so the probability is 2 out of 36, or you could reduce that to 1 out of 18 if you prefer. You'd keep going and fill in all your probabilities until you've filled in your whole chart. So this is an example of a probability distribution. It shows all the possible values for the variable from 2 up to 12 and the probabilities associated with each of those variables. Now, one thing to keep in mind is once you've made a probability distribution, you should notice that the sum of all the probabilities will always be 1. That's because if you've accounted for all the possible values of the variable, then the probability that it will be one of those things has to be 100%. So the sum will always be 1 or 100%. And that's a good way to check if you're given a probability distribution, if it's for a discrete random variable or not. With discrete random variables, all the different values are mutually exclusive. So for example, we couldn't have had both a sum of 2 and 3 at the same time when we roll 2 dice. It's either one or the other. And that's why the sum will always have to be 1 if you've accounted for all the different possible values of the variable.